Hello, geometry. Geometry. Okay, we are about to go through some final review here, particularly for the final exam for the summer school course. I'm just going to do a quick run through of pretty much all, if not most, of the problems. I may skip a few for the practice final. So let's go ahead and do that. My name is Mr. Butler. Yeah, I don't know what the date is. Today's the 11th. Don't forget to get your free Slurpees. And my score, hopefully 100%. That's what you guys want to aim for tomorrow as well. All right, let's take a look at this. First, this says simplify. Now, I'm going to use some problem solving for the first problem. I'm going to show you something interesting. If I see a negative and a positive of the same number, those are actually going to cancel each other out. So they would cancel each other out, but I'm going to break this down a little bit just to show you guys what you need to be able to do with other numbers as well. What I was saying there is it's almost like an x minus something minus x, and that negative x and the first x are going to cancel each other out. Those are going to be 0 overall. But anyways, let's go back and redo this normal way. If I were to break this down, I would still have 2 times, now I can break this into 2 square roots. These 2 square roots could be 4 and 5. That's helpful because 4 is a perfect square. I'll leave the middle one alone because I can't break that down anymore. Then the last one breaks down the same way as the first one, 4 and 5. That 4 is really a 2, so I have 2 times square root of 5, minus 3 times square root of 2, minus 2 times square root of 5. Well, this front number and this last number here are going to be 4 root 5. And we got minus 3 root 2, and again minus 4 root 5. Let's take that back. We got 4 root 5. Okay, so altogether there, this 4 root 5 and this 4 root 5 would disappear, and we'd just be left with 3 root 2. Now, in general, you can just cancel those out from the beginning, but you still need to know how to break it up into 2 pieces and take the square root of something of a perfect square. All right, speaking of perfect squares, let's look at this one, 72. I know that 72 is really, let's see, let's break it into a couple here. How about 9 and 8? I know that 9 is a perfect square. That would be 3 times square root of 8. Now this 8, I could break that down further, so I still have the 3. And if I break the 8 down into 4 and 2, the square root of 4 is 2. So I have 3 times 2, and then a square root of 2 here as well. Okay, so simplifying the final step here would be 6 root 2. Last step. These are easy. These are algebra review, but you need to do algebra in geometry, so you guys need to be able to do all of it. All right, so negative 5 is going to get distributed to these numbers here. So that means I'm going to have negative 5 times 1, which is negative 5. Then we have negative 5 times negative 4, and that's positive 20. N equals negative 145. Okay, now if I start adding to both sides, and I got 20n equals negative 140, divide by 20, divide by 20, and we got n equals, how much is this going to be? Negative 7. So that would have been our answer, negative 7. All right, so that's algebra. Let's start moving into geometry now. Okay, so we're going to take this first one. This is actually a little bit of trigonometry, because that's where you start geometry, or start trigonometry is in geometry. I got 3 sides here. I got 50, 14, and 48, and I got an angle. And the question is, what's that angle? Well, I need to make a choice. Let's choose 2 of these sides. Who cares which sides I choose? Doesn't really matter. How about let's do 48 and 14? If I were to look at those pieces, that's my opposite because it's across from the angle, and the adjacent. It doesn't really matter which 2 I choose, but I'm going to use those 2. If I'm using opposite and adjacent, then I need to determine which of the 3 trig relationships I'm going to set up, either sine, cosine, or tangent. And in this case, with the opposite and the adjacent as my 2 choices, I need to use the t, which stands for tangent. So that means tangent of that angle, whatever it is, equals 14 over 48. Now we can actually reverse this on both sides. We can calculate the angle based on the inverse tangent. Another way to rewrite that would have been tangent inverse of those numbers, 14 over 48. It's going to equal our angle. Well, let's go to our calculator and see what we get. So we are going to do, let's stretch this a bit bigger, clear all that, don't really need it. So we got second inverse on the tangent. So we got tangent inverse, not just regular tangent, but tangent inverse. So 14 divided by 48, and we come up with 16.26. One thing to check really quick is that your mode is in degrees here. If it's not in degrees, that's not going to work for you. So we go back to our thing. We got 16.26 degrees. 16.26 degrees. And that kind of looks like about 16 degrees, so that makes sense. Let's do another one. Okay, actually another 2. So we got 6 and number 5. Let's start with number 5. Okay, again, we're going to base our relationship using the SOHCAHTOA template and the pieces that we're given. We have this angle and then these two sides. Now, this side is across, so we have the opposite, and this side is touching it right there, so that's the adjacent. We're not using the hypotenuse. That means we can't use sine, we can't use cosine, we have to use tangent again. So the relationship then would be tangent of the angle measure, which is 49 degrees, is equal to the opposite over the adjacent. Opposite on top and the adjacent on bottom, so that's going to be x over 13. Now we need to get x by itself, so we're going to multiply both sides by 13, and then if we look at the calculator, we can simplify this. We can calculate 13 times tangent 49. It gives me 14.95. So x is approximately 14.95. Now we could round that off and it'd be, I guess you could say 15. But yeah, that's our answer. Let's look at this next one. Find the value of each trigonometric ratio. You do not even need a calculator for this. It says tangent of x. That means we're using x here. And tangent, as we remember, is going to be the opposite side over the adjacent side. So if I look at x, the opposite side is going to be here, and the adjacent side is going to be here, the 15. So that means that tangent of x is going to be the opposite over the adjacent. Let's fill in those two pieces. The opposite is 36, and the adjacent is 15. All I got to do now is simplify this. I look at this and I know 3 goes into each of those, 12 on top and 5 on bottom. So 12 over 5 would have been our answer. Because on multiple choice tests, they often are simplified all the way to the smallest numbers. Alright, let's look at the next 9. Ooh, we got another sneaky one back here too. Let's start with 7. Now that we're getting into, we want to be comfortable with naming them, doing calculations with them. The name have 4 sides, all equal. Now, that's kind of like a square, except these angles aren't necessarily equal. These two look equal, but these other two look different. So we're going to call this a rhombus. Rhombus. Because a rhombus has 4 equal sides. And that's the only thing that we really know. Alright, let's look at the measure of each angle indicated. Well, they're each quadrilaterals. Something to think about is that quadrilaterals interior is going to add up to 360 degrees. How do I know that? Because if I draw any quadrilateral, I can split it up into 2 triangles, each of which would be 180 degrees. So we double that, we'd get 360. Well, let's look at this one. That means I have this corner piece, we'll call it x. X plus 96 plus 60 plus 110. All together, all 4 of those is going to add up to 360. Well, let's simplify these here. Let's combine some like terms. That's going to be 156 plus 110, or 266. So x plus 266 equals 360. When I subtract 266 from both sides, I would get x to be simplified to 94. So 94 degrees is my answer for x. And you might be asking, does that make sense? Does that look like it's about 94 degrees? It does look like it to me. Okay, this next one, we'll do in a different color just to kind of differentiate our work. But we're going to do the same idea, but it's got an additional kind of layer to it because we got a lot more algebra, not just numerical expressions, but also algebraic expressions. So I know that all 4 of them are going to add up to 300. Doing that. That means 8x plus 15 plus 9x plus 100 plus 75, all together that equals 360. Getting a little crowded here, so let's simplify and shorten our equation. The 8x and the 9x, that'll be combined to make 17x. 15, 100, and 75 It's going to be 175 plus 15, or 190. So that's our simplified equation a little bit. Let's simplify even more. I'm going to subtract 190 from both sides. That means I'm going to have 17x is equal to 170. Well, that's kind of convenient, because when I divide both sides by 17, x is just going to be 10. Now that's helpful. That's really helpful. I'm nearly there. But what I really need to focus on is the actual measure that they're asking me to find. And that's measure of angle u. So I need to use 8x. Measure of angle u is equal to 8x. Therefore, that's equal to 8 times 10, or 80 degrees. And that makes sense. This looks like an 80-degree angle. Almost 90, but not quite. So that would have been our final answer for that one. Let's look at the next one here. Solve for x. Oop. Try and give ourselves plenty. Number 10. Number 10. Let's do red, just for fun. We're doing the same exact thing. Notice we got 4 pieces. This time, though, this corner is a right angle. That means that it's 90 degrees. Okay, so I need to add these 4 pieces together to add up to 360. That means I got 100 plus 80 plus 90 plus 16x minus 6 is equal to 360. So now as we're looking at that, I can combine, since this is going to be 180 plus 90, that's 270, plus 16x minus 6 equals 360. I'm going to go ahead and get rid of this 270 just to kind of simplify these numbers to something smaller. 16x minus 6 is going to equal 90 degrees. It's interesting. This corner right here is 90 degrees, so it would be a right angle corner. All we have to do this time is solve for x. So I'm going to add 6 to both sides. I'm going to see 16x, equals 96. So 16 times something equals 96. Now, I'm guessing that if I do divide these, that I would get x equals 6. So let's double check that. 16 into 96. Does that go 6 times? I don't know. 6 times 16. 6 times 6 is 36. And then we get a 9. So, yep, that does work. X equals 6. Now for this next one, there's something going on here that's not entirely obvious, but still very relevant. We see this side is 180 degrees that I just colored in red. I'm going to color the other side in blue. So this piece and this other piece here is also 180 degrees. How do I know that? Because it's splitting the circle in half, 2 halves. Each half is 180 degrees around the arms. That means that this expression with 22x minus 2 and the other one, 14x plus 2, if I put those together, I get the total half circle. So that's going to give me 180 degrees. So I have 14x plus 22x, that's 36x. We've got plus 2 minus 2, that's actually 0. So 36 equals 180 degrees. Divide both sides by 36, and x is going to be equal to 5. 180 over 36 is equal to 5. So there's the algebra. There's the work. Remember to pause the video if you ever need. I'm moving forward. Find the measurement in each parallelogram. Alright, so this is a parallelogram. That is huge. Parallelograms. Okay, so let's talk about parallelograms for a second. First of all, opposite pieces are congruent. Second, consecutive angles, corner angles, I guess I should say, corner angles are supplementary. So let's see which one of those two properties is really key here. Okay, so we got angle L and angle K. We put those together, those would be a supplementary relationship. And if it's supplementary, that means that it's something plus something equals 180. So let's fill these in. The first thing is going to be 118. The second thing is going to be a big question mark. So I got to subtract 118 from both sides. What would we get? That should be 62. So the question mark is equal to 62 degrees. Let's do this next one in a different color. How about orange? So number 13 here. Again, I have two angles, and it's even the same letters, L and K, and they're supplementary. That means that I have something plus something equals 180. Now notice this first one, I'll use 102 right here. Here we have 47 and another piece, we'll call it x. That means I have 47 plus x. Now if I were to simplify this, that means I have 149 plus x equals 180. So if I solve for that x and get it all by itself, I'm going to subtract 149 from both sides. That means that x is equal to 31. Let's do a couple more, then we'll finish that for part 1. We're going to do these in about groups of 15, just to keep the videos nice and short and work our way toward doing all of them. Alright, for this next one, it is almost identical, it's just like a higher level. So we have 3 angles here, but we can really think of them as V and U, and those again are going to be supplementary. That means that something plus something equals 180. So the first something is 6x plus 2. This second one here it's got a 62 degrees and a 9x minus 4. So I got to combine all of that together. So 6x and 9x, that's going to make 15x. 2 plus 62 minus 4, it's actually going to simplify to 60. So 15x plus 60 equals 180 degrees. If I subtract 60 from both sides, then I get 15x is equal to 120. When I divide by 15 here, let's see, how many times is 15 going to go into 120? 30 goes in 4 times, so that goes in 8 times. X equals 8. There we go. Alright, let's go ahead and finish with this one here, then we're going to pause it. You guys can go on to video number 2. So this says dA equals this, dF equals this, find dA. It's asking us to find pieces of a parallelogram. Now this looks like a rectangle, but any parallelogram, we know that the diagonals split each other in half. So that means that this CA is also equal to this AE. It also means that FA is equal to AD. So let's go see what we have. We know that DA, this side right here, is 4x minus 5. And then it says that the whole thing from D to F is 7x minus 3. Well, if I know that DA on the top right is 4x minus 5, so is AF. That's also 4x minus 5. Now I have a line split into 2 pieces and a whole. So I can add the 2 pieces together, and that's going to equal the whole. So I got 4x minus 5 plus 4x minus 5, and that's going to equal to 7x minus 3. And so let's start simplifying. That gives us 8x minus 10 on the left side and still 7x minus 3 on the right. I'm going to add 10, subtract 7x, and subtract 7x. That'll give me x on the left side and 7 on the right. Solve for x, we found that. But that's not what it just said. It said find dA. And this reminds me, I actually have to go back to the problem before this and do a little bit extra. If I know that dA is 4x minus 5, I got to plug that in. It's going to be 4 times 7 minus 5, or 28 minus 5, which simplifies to 23. So that's dA. dA equals 23. Let's see how this affects what we should have. We figured out that x equals 8. But what we didn't figure out is what's the actual measure of angle W. Well, W is over here. And if this is a parallelogram, remember the opposites are congruent. So W, measure of angle W, is equal to the measure of angle U. So that means that measure of angle W is the same as 6x plus 2. We know that x is 8. Yes, 6 times 8 plus 2, which is 50. So, there we go. It's 50, oh, by the way, degrees. Alright, that's the end of video 1. We'll be doing videos 2, 3, and 4 right after this. Stay tuned.